Okay, we're going to look at this now. Put in your calculator from the beginning. This is going over the very basics that we have of our exponents. Go to your calculator and let's put in there 5 to the 0 power. Let's remember how to do that. 5, the caret button, and 0. And when you press that, what is anything to the 0 power? 1. So I have 5 to the 0 power. That equals 1. Now, x to the 0 power, we can't put that in the calculator, but we just have to know that anything to the 0 power is 1. Okay? Take a minute and rewrite and simplify these right now. Okay, so on number 3, it says y to the 0 power. Again, anything to the 0 power is 1. Now, 2 to the first power, how can I rewrite that? Just a 2. Okay, any number, when we write it like 3, that's the same as 3 to the first power, just that we didn't, when you were growing up in kindergarten, we didn't teach you that 3 was 3 to the first power. We just taught you it was 3. So x to the first power, we can rewrite that as x. That's what you should have for these 3. Oh, that went backwards. Okay, there's 6 and 7. I want you to rewrite this by simplifying, and I want you to simplify to make sure that you have positive exponents. Okay, so for number 6, it's y to the first power. I can rewrite it. It's just y. Now, 5 to the negative 1. If I want to rewrite this using positive exponents, it's going to become, now let me remind you, this is 5 over 1. To change it to a positive exponent, it becomes 1 over 5. Now, one of the ways to do in the calculator to see that is that if you would have gone here and done 5 caret negative 1, press enter. It would have given you a decimal, press math, enter, enter. It would have given you 1/5. Okay, but these are variables, so that's not going to be able to be put in the calculator. So think about what I did about moving them to the denominator, and please simplify these two. Okay, so on number 8, what you're supposed to have, this is over 1. So when we switch it around to make it a positive exponent, it becomes 1 over x to the 6th power. The way you change it to positive is by flipping it. If it's in the numerator, it goes to the denominator. So number 9 would be the same thing. It becomes 1 over y to the 3rd power. All it's doing from switching from numerator to denominator is changing the exponent from positive to negative. Next, there's number 10. So as we look at number 10, I notice it's already in a fraction. If I want to rewrite it so I have a positive exponent, what should I do? I will flip it over, and it becomes x to the 3rd over 1, which is the same as x to the 3rd, because it's in the denominator, and all I'm doing is flipping it to the top. You just write x to the 3rd, yes. Not over the 1. No, you don't have to write it like that. Okay, so there's the next 2. Try the next ones. On number 11, again, it has a negative exponent, and it's in the bottom. So flipping it around, it changes to the numerator, so you just have y to the 4th. The next right here. Now, 0 to the x to the 0 power, anything to the 0 power is 1. That's the same as 1 over 1, which is the same as 1. So that's your answer for number 12. Yes. Okay, so there's the next one. Now, when we are multiplying the bases, now let me go back and explain. Remember, like in this, x to the 3rd. The x is the base. The 3 is the exponent. Okay? We are multiplying. When we multiply the bases, the bases, so these bases are both x's. There is a shortcut. What are you supposed to do with your exponents? You are supposed to add the exponents. So I'm going to write right here, you're going to add the exponents. So what does that mean? My base stays the same. It's x. And I add 3 plus 7. It's going to give me x to the 10th. That's my final answer. Because x to the 3rd is 1, 2, 3. X to the 7th, 1, 2, 3, 4, 5, 6, 7. If you add them all up, that gives you 10 of them. So when your bases are the same and you're multiplying, you add the exponents. Okay? Wait, we just did that one. All right. There we go. Do this one. This one again, my bases are the same. So I'm multiplying my bases, and I'm supposed to add the exponents. So I have x to the 6th. Next, right here, let's try this one. Do this one now. On this one, when I'm going to look, I'm seeing which bases are the same. And I see that x squared and x to the 3rd are the same. So those bases are the same. So I have x to the 5th power and then y to the 4th. That will be my simplified answer. Next one. Now on this one, we're dividing. So there's going to be a rule when the bases are the same. Subtract the exponents. Yes, when the bases bases are the same. Goodness gracious. Subtract the exponents. The reason why that happens is because x to the 5th is 1, 2, 3, 4, 5, all over x squared. And these x's cancel each other out. And what do you have left? You have 3 of them up there. Well, 5 minus 2 is 3. So it's x to the 3rd. Try number 17. Do that now. Okay, so on this one, the bases are the same. We need to subtract the exponents, and I get x to the 1st power, which is the same as just writing x. So you don't have to write x to the 1st power. You can just write x. 18. Let's see. Go ahead and try and do 18 right now. Okay, on number 18, I've got my x's. 2 minus 5 is x to the negative 3rd power. And then your y's, 4 minus 7, y to the negative 3rd power. That's one way you could see it on the EOC. Another way is if we go ahead and write it with positive exponents. It becomes 1 over x to the 3rd, y to the 3rd. Now let's look and see why that happens. X squared y to the 4th means 1, 2 x's, 4 y's, x to the 5th, y to the 7th, 4, 5, 6, 7. Okay, so now when you cross out like 1x takes away an x takes away an x, how many x's are left on the bottom now? 3. That's why there's x to the 3rd power on the bottom. Now I have my y's. A y takes away a y. 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 How many y's are left? 3, and where are they left at? On the bottom. That's why this works. That's what happens right here. Okay. Now number 19, this is a power raised to a power. Okay? This means there's only one base. Looking at this, there's only one base. And I have, it'd be the same as writing x to the 4th 3 times. 1, 2, whoops, 3. Now, if I added them all up, how many x's do I have? X to the 12th. Well, the power to a power rule means says if there's only one base right here, you multiply those exponents, so that's how it becomes 12. When it is a power to a power, when it is a power or an exponent raised to a power, you multiply the exponents. Okay, so when it's a power raised to a power, you multiply the exponents. So there's number 20. Answer number 20. Number 20, again, a power raised to a power. All you do is multiply these two exponents, so it's x to the 10th. Next. Okay, let's look at this one. We have some coefficients with it now. You treat these the same. One of the biggest mistakes is people try and add them. You're not adding those coefficients. You're just taking -4 times 6, and you should get -24. Now, the bases are the same, and you're multiplying, so this is when you add the exponents. Okay, the exponents are the only thing that you add. So I get x to the 11th. Multiply the coefficients like normal, and add the exponents. Number 22. Now, looking at this one, my coefficients right here, I have 32 divided by 8, which is 4. You treat that the same. So do that like you would any other number. Anywhere you would see 32 divided by 8, you just divide like normal. Now the exponents we're going to subtract. So we're going to have 8, and there's 1. 8 minus 1 is 7, so it's x to the 7th. Y, 7 minus 2, y to the 5th. That's what your answer should be. It's not a -7, it's 8 minus 1. Now, here's one thing. Do you remember back before I used to ask you guys, if I had this, x squared plus x, can you put those together? You can't put those together because that's an x squared, and that's the x tile. If the exponents are not the same, you cannot put them together. So if it says like x to the 4th plus x to the 3rd, that's your answer. You can't do anything else with it. They have to have the same exponents. Now, what if I had, what is x squared plus x squared? Is not x to the 4th. It's 2x squared because it says I have 1x squared and 1x squared. So when I put them together, if I'm putting them together, I have 2x squared. Just like if I had x plus 2x, what do I get? 3x. So if I had x to the 8th plus x to the 8th, oh, that's 8 to the 8th. Woo, all right. X to the 8th, really? There we go. This would be 2x to the 8th. Not the 16th. You don't add those exponents. That's only when you're multiplying, yes. That's the only time you do that. Okay. Something